Number 9, graph the inequality 3x plus y is greater than 0. Now, we want to pretend like this is an equal sign to graph the boundary line. A lot of times we look at this and say, well, we've got the variables on both sides. This is standard form equation. It's good for finding your intercepts. So if you want the x-intercept, you make y 0. And you go, well, 3 times 0 is 0. So there's my x-intercept. But the problem here, if you want the y-intercept, you make x 0. Okay, so the y-intercept is also 0. We don't have two distinct points that we can connect to make that boundary line. So I think what I'll do is just quick put this in slope-intercept form by solving for y. Minus 3x on both sides. And I see that, oh, okay, y equals negative 3x. And there's no constant term out here, so it's like your y-intercept is 0. We already showed that. But the slope's negative 3. So we go down 3 over 1. And now we've got a couple other points in the graph. Is it going to be a dashed or a solid line? You look at the inequality symbol. Since it can't be equal to, since it's just greater than, we're going to use a dashed boundary line. And then we have to decide where we're going to shade this. Now usually we like to test the point 0, 0. But since 0, 0 is on this line, we can't test it. So let's pick another point. Let's make our life easy. Let's try 1, 1. 3 times 1 is 1. I'm sorry, 3 times 1 is 3. Plus 1 is the y-coordinate. Is 4 greater than 0? And the answer is yes. So since the 1, 1 side worked, we're going to go with it. We're going to shade that entire side. Any point in the blue region, if you substitute the x and y coordinate into this inequality, will make it true. Describing it, we've hit quadrant 1, a little bit of quadrant 2. We've hit quadrant 4, and we excluded the boundary line. 1, 2, 4, exclude the boundary line. We're looking at letter R.